Thank you for joining me in this session and welcome to this session on daytime astronomy, sun, shadow, and the sky. Daytime astronomy, the moment you hear this word, you might think that why during daytime? That too astronomy. Astronomy is associated with the stars and the night sky. First, there are lots of interesting activities that you can do during daytime. Second, schools function during daytime and then they provide easy access to young people and also place to carry out interesting activities. Unfortunately, in some cultures, still there are fetters for girls to come out during night. Of course, we don't agree with that concept. We believe that girls have the same rights and should have the opportunities like boys. But however, given the actualities and realities, perhaps it may be good to start with the daytime astronomy, convince the parents and the community, and provide equal access to girl children. And lastly, nighttime involves issues of safety of children, and then the teachers might be hesitant to take that kind of responsibility. So, if you want to do in a large scale, reach to large section, daytime school offers a good opportunity, and there are also a lot of very interesting activities that one can do. Very educative and enlightening activities during daytime. We might think that what do we have in daytime? In fact, we have the nearest star to Earth, Sun, and the shadows made by Sun, and they provide immense opportunity for learning. Let's start with a very simple question: where is the East? Many people will immediately say that, oh, that's where the sun rises. But is it so? Let's explore. Go to the top of your roof, choose a place, mark that place because you have to come back again and again to the same place, or in an open area, mark a place. Okay. Watch the eastern side before the sunrise, and as the sun rises, place a rock on the parapet wall in such a way that you, the rock, and the sun are in the straight line. Wait for some days, maybe 15 days, come back to the same point, watch the eastern side. Is the sun actually rising in the same point like last time? No, it's in a new place. If you keep on this observation for some months, you will find that the sun is either moving towards southeast or the sunrise point is moving towards the northeast. It's not exactly on the east. So if you carefully observe and then tabulate, you will find that there are 2 days in a year, equinoxes day, in which the sun rises in the due east. And this is how, in the ancient time, people found out what is a solar year, what is the length of the solar year, right? And in the skyline, if you keep observing, you can very easily notice that the sunrise points are different. And even if you are in an urban area, the urban skyline, I mean, if you can watch through your eastern window from in the urban skyline, can give you markings on which you can understand how the sun position changes over the year. This is one very, very interesting activity. Kids get really excited. They know it, but then when they do it systematically, the learning is deeper. A lot of things can be explored. The another thing is shadows tells you time. I come from Tamil Nadu, which is a place in the southern part of India, and we speak a language called Tamil. And in Tamil, there is a old couplet which link the shadow and time. Okay, basically what it says is that you measure your shadow with your own feet, and depending on the shadow length, you can guess the time that has elapsed after the sunrise or after the noon. You can create your own formula for your own location by systematically studying shadows over a period of a few days. Students can measure. Remember, for each student, you have to use the same student's footstep for measuring the shadow. But of course, you won't get a perfection of minutes and seconds, but something like about 20 minutes to 30-minute block, you can get time. And kids love it. I mean, it's something that they can interestingly do it. Next important question that one can challenge the students are, what is noon? People will say that when it is 12 o'clock, but 12 o'clock is clock time. Astronomically speaking, that need not necessarily be the noon in your area. So how do I find out? Have a vertical pole, make a circle, which is the same length as, the radius is same length as this pole, and then mark the points, shadow points, okay, at 11:30, 11:40, 11:50. So start from 11:30, go up to 12:30, okay, and then plot it in a graph. So here is the shadow length, here is the time, here is the graph. So whenever you get the shortest shadow, that's the local noon. Very interesting. People find it that it's something amazing, which they never thought of. Here is where the kid is doing in a slightly more systematic fashion. So we have put a concentric circle, and this is where the vertical pole was placed. Okay, so the kid is marking time from 11:30 to 1 o'clock, right? So let's take a closer look. What you find here is that the shadow point at 12:05 and shadow point at 12:20 touch the second circle. Yeah, second circle, 2 points in the southern circle. So I add them, 12:05 and 12:20 divide by 2, I get roughly 12:12. That's the local noon at this point. Yeah, so it's something very interesting, something very interestingly we can do it. In India, we use the 82° as our Indian Standard Time meridian, standard meridian. So any place in India which is east of this line, the local noon will be less than 12 o'clock. And any place west of this line, the local noon is going to be more than 12 o'clock. So this is something that we can do it in school in the daytime. And the same activity can also be used to find out the cardinal directions. Okay, so I join these 2 points, 12:05 and 12:20, when they touch the second circle. It need not be second circle, it can be third circle, fourth circle. You can take any 2 points on that any circle. Okay, so I join them. So when I join them, this line is the west east. If I bisect it, then I get the north south. So you can find the cardinal directions from this activity. And a lot more interesting activity you can do if you follow up this activity over a period of a year. Let's say every 10 days, every 15 days, if you do it, a lot more interesting thing you can do. What you would find is that on 2 days in a year, we did this in Chennai. I'm talking about with reference to Chennai. On April 25 and August 17, if I plot the dots of a vertical pole here, okay, vertical pole kept here, if I plot the dots, it's a straight line. On all other days, it's like a curved line. Okay, so it'll be like a curved line like this, right? And what I will find is that between August 18th and April 24th, the shadow falls towards south. And between April 26th and August 16th, the shadow falls toward the north. There is a flipping. The flipping takes place on these 2 dates. And these 2 dates, we call it as zero shadow day, because at the local noon, the vertical pole will not create any shadow. Right? So it's a very, very interesting activity. So if you can do it as a kind of a long-term project, a year-long project in school with the children, and it's very exciting and educative and entertaining. How long it will take for sun to set? You extend your arm fully and keep your palm like this. let's assume that the western horizon is here and the sun is about 4 fingers high, then it is going to take about 1 hour. For every finger, it's going to take about 15 minutes. So you can have discussion of what does that one finger mean, why 15 minutes, and so on and so forth. A lot of interesting exploration one can do. You can create a small solar observatory in your school. What you need is a ball. Okay, so we make a small hole in the ball here, fill it up with sand up to this level. Then you cover this hole with a cardboard, pasting a small mirror with a circular aperture. Okay, so circular aperture. Then you project the sunlight into a dark room. You get the image of the sun. Okay, so this is a solar observatory. With this observatory, a lot of interesting activities you can do. But one important challenge would be that during daytime in school, maybe you don't get a really dark room. So what do you do? What you do is that you take a big cardboard box like this, cut a big hole, paste a paper on the backside, white paper on the backside. Then it's a portable dark room. You can use them. So from the projection of sun and the movement of the sun, you can compute the period of Earth's rotation. You can observe sunspot. A lot of interesting activities you can do. You can watch moon during the daytime. I mean, it's a exploration that we suggest to the kids. So we tell them that search for moon in the daytime, prepare a data set, analyze, and they find out that actually the moon is visible from waxing half moon to waning half moon. Of course, the new moon, you don't see it. Near the new moon, you don't see the moon, but you can find out a lot of interesting stuff from this, the moon's movement and so on. One important activity that we add as part of our daytime activity is to instill a feeling that we are one under the sun. Whether you are black, whether you are white, whether you are yellow, you are tall, you are short, you are male, you are female, whatever religion or faith that you belong to. So we take a stiff cardboard like this, make holes which depict the various faiths. Okay, you keep the card very close to the wall. You see the individual faith symbols, but you increase the distance. What you find is that all of them are becoming circles. And you increase the distance even more, all the circles combine and become one single circle. So we are one under the sun. And I think it's a very important message to talk in this time of strife, violence, and hate. Thank you for being with me in this session. Thank you.